Hello and welcome to the second video of 5.3, the pH scale. In this video, I would like to focus on the right-hand side column, student intended learning, and the first point, which is the undertaking. Calculations using the relationship pH equals to negative log of H plus concentration, and also its rearrangement. H plus concentration equals to 10 to the power of negative pH. Now, before we get into that, let me just go through some background information that is quite important for you to know. All right, so the pH scale and also concentration, they are related somehow, and would like to talk about why and how. So back in the days, scientists, they have discovered that 1 in 100 trillion, which is 10 to the power 14, it's a quite important number, so that's why it's in yellow. Make sure you write that down with underline or highlight. Water molecules would ionize in pure water. So if you have got certain amount of water, 100 trillions of water molecule in there would be ionized. When I say ionized, this is the reaction that we are talking about. So there are two water molecules, and some of them would be making the product this side, product. So H3O plus and also OH minus, and some of those products will be coming back to the reactant direction to make 2H2O plus. Sorry, water molecule, that is. They then determine that the ion product of pure water is always 1 times by 10 to the power of negative 14. So, small number there, but at 25 degrees Celsius, so at the room temperature, there always is the water molecule present is supposedly 1 times by 10 to the power of negative 14. That's the concentration. Therefore, if you multiply the concentration of H3O plus and the concentration of OH minus, you would always get 1 times by 10 to the power of negative 14 grams per liter. They are all in concentration. They are all working in the same unit. You might have noticed that there are square brackets around those symbols of species. The square brackets means moles per liter. On the next diagram here, what you can see, I'll zoom in a bit. What you can see is that approximate H plus and OH minus concentration and pH values of some common substances. So at the top, you see 1.0 molar HCl. pH is given at 0. H plus concentration is 1 times by 10 to the power of negative 0. Well, any 0 as exponent will give you 1. And concentration of OH minus is 10 to the power of negative 14. Therefore, if you multiply them, you will get 10 to the power of negative 14. Okay, that's quite hard to picture. So we'll move on to maybe vinegar. pH is 4, so acidic still. H plus concentration is 10 to the power of negative 14. And OH minus present is 10 to the power of negative 10. If you multiply them together, you get 10 to the power of negative 14. If you look at, say, soap, down in the basic area, pH is 9. 10 to the power of negative 9 is the concentration of H plus, and OH minus here has got 10 to the power of negative 5 as its concentration. If you multiply, you get again 10 to the power of negative 14. So hopefully you get the idea here that if you multiply the concentration of hydrogen ion and concentration of hydroxide ion, you always get 1 times by 10 to the power of negative 14. Remember this formula because it will come in really handy. Next slide. Okay. A neutral solution is found to have 1 times by 10 to the power negative 7 moles per liter of hydronium ion, which is quite important for you to know, because if you multiply that with the concentration of hydroxide ion, which happens to be the same, what you get, you still get 10 to the power of negative 14. Therefore, you can plot this 10 to the power negative 7 concentration into where that is. So in this equation, which was rearranged here to find out concentration of OH minus, you can then do 1 times by 10 to the power negative 14 divided by the concentration of H3O plus. In this case, it's 1 times by 10 to the power negative 7. As an answer, you should get OH minus concentration is the same as concentration of hydronium ion, which is 1 times by 10 to the power negative 7 moles per liter. Again, square brackets denotes concentration in moles per liter. So, in pure water which should have pH of 7, there should be 1 times by 10 to the power of negative 7 hydronium ion and also hydroxide ion, which hopefully you can relate to that, and I hope you see where we're going. In this diagram there as well, you can also see that the concentration of H plus and OH minus kind of like fight with each other. When more H pluses are present, there will be less number of OH minuses, and when there are more concentration of OH minuses, there should be less concentration of H plus. You might want to copy this diagram down to your book.